For this section of work, you'll notice that there are pronumerals on both sides of the equations. In the first example, there's a 6y and a 3y on either side. So our first job is to try and make it so that there is a letter only on one side of the equation. Fortunately for these questions here that are shown, it's not that difficult. If I look at the equation, I've got 6y equals 3y plus 3. Now I can do what I've been doing all along, which is to do the same thing to both sides of the equations with letters as well as numbers. So what we're going to do is subtract 3y from both sides. What that does is it means that on the right hand side, 3y take away 3y is actually 0. So all that's left on the right hand side is 3. On the left hand side we've got 6y's and we take away 3y's. That leaves us with 3y's. Now the problem is a lot simpler. What's stopping y being the subject or being on its own is the 3 multiplied by it. So just divide both sides by 3 and you get the 3's cancelling on the left and y is equal to 1. And if I check that up the top, I'll get 6 times 1, which is 6, is equal to 3 times 1, which is 3, plus 3, which is 6. So that works. For the next question, we're going to do a similar thing. 5d plus 3 equals 4 minus 2d. This time I'm going to add 2d to both sides. When I do that, the minus 2d and plus 2d on the right hand side equate to 0, leaving just 4. On the left hand side, the 5d and the 2d make 7d. There's still a plus 3, and so what we've got left is all the d's together on one side and some things to get rid of. So to make d the subject, I need to get rid of the 3 and the 7. I'll get rid of the plus 3 first because reverse BODMAS says that plus and minus go first. So let's do that. So 7d plus 3 minus 3 equals 4 minus 3. Remembering to do it to both sides. Plus 3 and minus 3 make 0. That's why we did it. 7d is now equal to 1. Now I need to divide both sides by 7 to get rid of the multiply by 7. So that leaves me with the 7's cancelling and becoming 1. So 1 times d is d, so d equals 1/7. Again, you could check this answer by substituting into the equation at the top, but as it involves fractions and a lot of mucking around, I'm going to leave that for now. With these examples, we have a problem because the pronumeral, the r in this case, and in the d in the second equation, are inside the bracket. They're a bit trapped in there, so I'm going to liberate them first and remove them from the brackets by expanding. So when you've got brackets and pronumerals on both sides, expanding the brackets is a good trick to use because it actually makes it easier to get the answer. So let's have a look at the first question. If I expand, I need to multiply 5 times r and 5 times 2. So 5 times r is 5r, 5 times plus 2 is plus 10, and on the other side I've got 15 minus 2r. This question now looks like the previous examples, and I've got r's on both sides. So to get them together, I'm going to add 2r to both sides. Always do things to both sides. When I do that, the 2 on the right hand side equate to 0, leaving just 15. And that means on the left hand side I've got 5r plus 2r, which is 7r plus 10. Now I need to get rid of the 10 and the 7, so let's subtract 10 from both sides. And on the left hand side they cancel out. So 7r equals 5, and therefore divide both sides by 7 to get rid of the 7, so r equals 5/7. That took a few steps, didn't it? We'll expand the brackets for the second equation as well. So 2 times d minus 5 gives me 2d minus 10. 3 times d plus 7 gives me 3d plus 21. This time I'm going to subtract 2d from both sides. The reason I do that is because when I subtract 2d from both sides, I'll get plus d on the right hand side, and I don't want to get negatives because that makes it too hard or too long. So let's subtract 2d from both sides. 2d minus 10 minus 2d equals 3d plus 21 minus 2d. So the 2d here and the minus 2d here becomes 0. So what's left is minus 10 equals 3d subtract 2d is just d plus 21. Now I need to subtract 21 from both sides to get d by itself, or in other words, to make d the subject. So the 21 minus 21 makes 0 again, and I'm left with d equals minus 31. I'll leave you to check this one out, but it involves doing this final equation and making sure that they both equal. So you can have 2 minus 31 minus 5 has to equal 3 minus 31 plus 7.